Hi people, notes 4.7 are on applications of quadratic equations, and this is the first day of this topic. And like we've always done with word problems, we're going to always underline or highlight our key information, write our let statements, set up our equations. So let's go ahead and look at number one. So it says the length of a rectangle is 16 meters more than twice the width, or 16 inches it should be. If the area of the rectangle is 40 square inches, we want to find the perimeter of the rectangle. So we're asked to find the perimeter of the rectangle, and only an algebraic solution will be acceptable. So for starters, I'm going to draw a sketch of what's going on here. This is the width, and this is the length right here. And we're going to write some let statements. So if we don't know the width or the length, we're going to say let the width equal W. And we're going to say let the length equal L. And we also know that the area of a rectangle is length times width, and we're told that our area is 40. So I can replace the area here with 40. This is really key information right here. It tells us that the length of a rectangle, so the length of a rectangle, is equal to 16 more than twice the width. So we have to write twice the width and then add 16 to that, okay? So now that we've done that, we can use substitution and substitute this into our area equation. So here, I can say 40 is equal to, and instead of the L, I can replace it with 2W plus 16, and then I can copy this W down. Now, when I do this, I have multiplication, and a lot of times it's a lot easier for us to just write this as 40 equals, and then we'll put the W in front because this is a single term, it's a monomial. And then it's a lot easier to see that we just have to distribute that W through. So when I distribute that W through, I end up getting 2W squared plus 16W. Now, because this is squared, it is a quadratic equation, I have to solve this by either completing the square, factoring, or the quadratic formula. I always try to factor first if I can, because that's always the easiest way or the quickest way to do this. So in order to factor, I have to have 0 on one side, and my leading coefficient is positive here, so I'm going to get rid of the 40, move it on the other side. So I end up getting 0 equals 2W squared plus 16W, and then I get minus 40 right here. Now, just a reminder, whenever you factor, the first question you always ask yourself is there a GCF? And here I can see, yes, there is a GCF. I can factor out there is a 2 in common. Once I factor out that 2, it makes things so much easier for me when I want to go ahead and solve this. So when I divide 2W squared by 2, I get W squared. 16W divided by 2 is 8W, and then the negative 40 cut in half is a minus 20. Now I'm just going to bring this over here because I'm just running out of room. And once I do this right here, it's so much easier for me to solve, or to factor, I should say, what's in the brackets here. So right here, I'm just going to use guess and check because my leading coefficient is 1. It's nice and easy. So I'm going to put a W here and a W here. I'm going to look for factors of 20. And some factors of 20 are 1 and 20, 2 and 10, 4 and 5. I'm going to use 2 and 10 because I can get a positive 8 from 2 and 10, which means that my two solutions here would be negative 10 and positive 2. Well, negative 10 is not possible. This is called an extraneous solution because the width of a rectangle can never be a negative value. So we know here that the width has to be 2 inches, okay? And we know that the length right here, we're told here that the length is equal to 2W plus 16. So I can just replace the W with a 2. So here we know that this length would be 4 plus 16, or just 20. So here we know all of that information, so we can go ahead and label that into our diagram up here. So our diagram is over here. So we can say here that the width is 2 and that the length is 20. And then to find the perimeter, all I have to do is add 2 twice and 20 twice. 2 sets of 2, 2 sets of 20. So here I end up getting 4 plus 40. So that means that my perimeter is 44. So we can say, therefore, the perimeter is 44 inches. So in number 2, it says a factory is to be built on a lot that measures 80 meters by 60 meters, and then a lawn of uniform width equal to the area of the factory must surround it. How wide is the strip of lawn? So that's what we want to figure out. How wide is the strip of lawn? And what are the dimensions of the factory? So there's a lot of stuff going on here. So for starters, we have a lot, and the lot measures 80 meters by 60 meters. So I want to draw a picture of what's going on here. So we have this lot right here, and we know this is 80 meters, and we know that this is 60 meters. Okay? Inside of the lot, we have a factory. And in the on the lot, we need to have a lawn that has uniform width, which means that this right here, this width right here, and this width right here have to be equal. That's what it means. And this is going to be the factory. And then out here, this is the lawn. Okay? So it's, and we know that the area of the lawn that we have here has to be equal to the area of the factory that we have right here. The green and the purple have to be equal to each other. Well, we know the total area, right? We can easily find the total area. All we have to do is just multiply the length by the width. And when I multiply those two together, I get 4,800 square meters. But because these two areas, the green and the purple area together, make 4,800 and each one is equal, then we can easily say that the area of the factory is going to be equal to half of this 4,800. So I'm going to take 4,800, divide it by 2, and I get 2,400. Okay, so now that we've figured that out, we need to find an expression for this factory. So if we know that the length of the full lot is 80 meters, and we have a width of W on the left side of the factory and a width of W on the right side of the factory, we know that the width of the factory has to be the whole 80 minus 2 of these W. So here we're going to say that this would be 80 minus 2W. Okay? And then we want to do the same thing for the width. So we know the full width is 60, but we're taking away one of these W's and another one of these W's. So by doing that right here, we've got 60 minus 2W. And that altogether should equal half the total area, which is 2,400. Now that we've done that, we can go ahead and solve this equation. So to be able to solve this, I have to FOIL all of this out. I have to expand this. So I'm going to multiply 80 by 60, and I get 4,800. Then I'm going to multiply 80 by negative 2W, which gives me negative 160W. Then I'm going to multiply negative 2W by 60, which is negative 120W. And then I'm going to multiply negative 2W times 2W, which is 4W squared. And that's going to equal 2,400. Now, in my next step, I'm going to do two things all at once. Actually, three things. First thing I'm going to do is put my my left side in descending order. So the first term that we have here is 4W squared, okay? Then I've got the W's right here, and I'm going to collect these together, and that gives me negative 280W. And then I'm going to get rid of this 2,400 right here, and I'm going to move it to the other side. So I'm going to subtract 2,400 from the 4,800, and I get 2,400. And this should equal 0. Okay, now I'm going to try to figure out how I want to solve this. So I can either factor it, complete the square, use the quadratic formula. I prefer to factor if possible. So I'm going to look and see. First question is there GCF? And there is. There's a 4 in common. So when I factor out a 4 from 4W squared, I get W squared. Nice. This is going to be an easy factoring question then. Divide negative 280W by 4, I get minus 70W. And divide 2,400 by 4, and I get the 600 that I have here. Now factoring this is a lot easier. I know I can only just use W and W. So there's a lot of factors for 600. We need to make a list of factors for 600. But to be honest, I'm going to start with 6 first. And I want to show you something really quickly with 6. So if I know that 1 times 6 is 6 and 2 times 3 is also 6, then I know that 10 times 60 is 600 and 20 times 30 is also 600. These are not the only factors, but I'm going to start with this right here instead of making a whole long list of factors. And if these don't work, then I would make a whole long list of factors. But they do work because I can use this 10 and this 60 right here. I can use a negative 10 and a negative 60, which means that W, by the way, let's check to make sure that this works right here. So this is negative 60W, this is negative 10W, negative 10 and negative 60 together give us the negative 70 that we are looking for. So that's great. So I'm going to put minus 10 here, minus 60 here. So W equals 10. And W equals 60. Now, right now, neither one of these appears to be an extraneous solution. However, if you remember right here, this was the length of our factory. So if the length was 80 minus 2W, and if W was the 60 that we got here, then it would be 80 minus 2 times 60, which would give me 80 minus 120, which is negative 40, which is not possible, which means that this is, in fact, an extraneous solution. So let's see if 10 is going to work. So for 10, I would do 80 minus 2 times 10, which gives me 80 minus 20, which is 60. That's good. Let's double check the width. It would be 60 minus 2 times 10, because this is the width right here. 60 minus 20 is 40, so this also works right here, which means that my dimensions are good to go for this right here. So the first question is, how wide is the strip of lawn? And this W right here represents the strip of lawn. So we can say, therefore, the lawn is 10 meters wide. And then we can say the length of the factory is 60 meters and the width is 40 meters. And we are done with this question. In number 3, it says the size of a television screen or computer monitor is initially stated as the length of the diagonal. So like, for example, you go to a store and you want to buy like a 60-inch TV. What that means is this is 60 inches. So from one corner to the other corner is 60 inches. It is not the length or the width, okay? So here, a screen is 50 inches long, and the width of the screen is 10 inches more than the height. So here, we'll call this the H, and we'll call this the W, okay? And we know that the width is equal to the height plus 10. So we're good to go for this information right here, okay? So notice how drawing a picture and writing out your information here is going to make a big difference for us. And by doing this right here, these are technically our let statements. I've just drawn it on the actual diagram right here, but technically we should say let width equal W and let height equal H. So now that I've done this, I need to use this information to help me figure out how to write an equation. So if you notice here, I have a right triangle. And in a right triangle, we are also looking at 3 different side lengths. So if you remember, Pythagorean Theorem tells us a squared plus b squared is equal to c squared. And here we know that the c is going to have to be the 50 right here, because the c is always across from the right angle right here. So this is going to equal 50 squared. So the width, we don't know, so we will call it W, and the height we don't know, so we'll call it H. So here we can say W squared plus H squared is going to equal 50 squared. But we do know that W is going to be equal to H plus 10. So instead of W, I can replace this with H plus 10 because it's the same thing. So this is H plus 10 squared plus H squared is going to equal 50 squared. So let's figure out what this is. Don't forget that H plus 10 squared does not mean H squared plus 100. That is incorrect. What this means right here is I'm going to do H plus 10 and multiply it by itself. So I'm going to do H plus 10, multiply that by H plus 10. And then I'm going to say plus another H squared, and that would equal 50 squared, which is 25 100. So I need to expand this right here. So h times h is h squared, h plus 10 is 10h, 10 times h is also another 10h, and then 10 times 10 is 100. Copy down the plus h squared, and that should equal 2500. Also, hopefully at this point in time, you should recognize that this should all turn into h squared plus 20h plus 100. Even from here, you should be able to go straight down to this line right here, because 10, when I double it, gives me this 20, and 10, when I square it, gives me this 100. I can copy down the h squared right here, and that would equal 2500. Okay, so now I just need to collect like terms. So I've got h squared here and h squared here, so that gives me 2h squared. I'm going to copy down the plus 20h, and then I'm going to get rid of the 2500 right here, and I get minus 2400, and that's going to equal 0. Now, to be able to solve this, I need to try to see if I can factor. Again, you can complete the square, you can use quadratic formula, it doesn't matter, but again, factoring is always the easiest option if possible. So when I factor out a 2, I get h squared plus 10h minus 1200 is equal to 0. This is nice because my leading coefficient here is 1, so I can try h and h. I'm going to look for two numbers that multiply together to give me 1200, which are 40 and 30. Those give me 1200, and then 40 minus 30 is a positive 10. So here h would be negative 40, or h equals 30. And this we already know is extraneous. This won't work, which means that our height has to be 30 inches tall. But the question is asking us to find the dimensions of the screen. So now we know the height is 30 inches, and we know that the width is 10 more than that. So here we know the width is 40 inches. So here we can say, therefore, the TV screen is 30 inches by 40 inches. And that's it for this question and this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.